8.7 Inverses of Trigonometric Functions Practice Solutions. For our first section, we are finding all possible values for each expression. For number 2, we have the inverse of sine of -1/2. So we're looking for that graph, or on that coordinate, we're looking on that unit circle where anywhere that our y value is -1/2. So remember, this is saying that we want to know the value of where y is -1/2. So with this, we are going to look at our unit circle. The -1/2 is our y value. Where is it? Right here. As well as right here. So we're working with, remember, radians, the 11 pi over 6 and the 7 pi over 6. So we're going to write both of these, 7 pi over 6, 11 pi over 6, and we're just going to add that plus 2 pi times n, where n is an integer. For number 3, we're working with the inverse of tangent of the square root of 3 over 3. So where is our y over our x, the square root of 3 over 3? Well, when we look at this, the square root of 3 over 3 means that we're doing y divided by x, so y times the reciprocal of x, and we're getting the square root of 3 over 3. So if we look at 30 degrees, that square root of 3 over 2 and 1/2, if we take the square root of 3 over 2 and take the reciprocal of that and multiply it by the 1/2, it's going to be the 1 over the square root of 3. From there, if we look at the 210, we have the same thing, 1/2, the -1/2 and the negative square root of 3 over 2. So when we divide those, or multiply by the reciprocal of the square root of 3 over 2, we're going to get the square root of 3 over 3 when we simplify. So we are working with both the 30 degrees and the 210 degrees. So we're going to use those radians, which is pi over 6, as well as 7 pi over 6, and we're going to add 2 pi times n to both of these. And then just add in where n is an integer. And then you're done. For 4, we're doing the inverse of cosine of the square root of 2 over 2. So for this one, where is x? Cosine is x, so where is x? The negative square root 2 over 2. Look at your unit circle. That's negative square root 2 over 2, where that is x, is going to be here and here. So we're going to use 3 pi over 4 and 5 pi over 4. From these, we're going to add both the 2 pi times n and where n is an integer. And then we're done. For the next part of this practice, we are evaluating each inverse trigonometric function, and we're giving our answer in both radians and degrees. So this one is our dead giveaway that we are working with these restrictions when it tells us to evaluate. So for number 5, we have the inverse of cosine of the square root of 3 over 2. So where is x? This square root of 3 over 2. And remember, that's just our first and second quadrant here for cosine. So where x is the square root of 3 over 2 is this pi over 6 and the 30 degrees. So we're going to give both pi over 6 and 30 degrees. For 6, we have the tangent to the negative first, or the inverse of tangent of 1. So this is going to give us the y over x that's equal to 1. Remember, if we're working with sine or tangent, we are working with just the first and fourth quadrants. So for the 1, our x and our y values have to have the same sign and have the same terms. So for this one, we are going to look at that 45 degrees. We have the square root of 2 over 2 divided by the square root of 2 over 2. So that's going to give us 1. So this, again, we said 45 degrees. So it's 45 degrees and pi over 4. For 7, we're working with the inverse of cosine where we get 2. Well, cosine is x, and x is 2. Well, if we look at our unit circle, there is nowhere where x is 2, so this is undefined. For 8, we have the inverse of tangent where we get negative square root 3. Well, with this one, we want our y over x to be the negative square root of 3. So if you look at our values, we have 1/2, we have the square root of 2 over 2, and we have the square root of 3 over 2. We want to cancel out those 2 somehow and just be left with the square root of 3. So if we're doing y divided by x, and we get something with the square root of 3 over 2 times 2 over 1, it would be division here. So the square root of 3 over 2 times 1/2. So our y value would have to be the square root of 3 over 2, and our x value would have to be 1/2. So look at your unit circle. Where's the x value 1/2 and the y value the square root of 3 over 2 when we're working with tangent? It is up here. So we have this the pi over 3 and the 60 degrees. However, we are thinking negative here because that is a negative square root of 3, so you want one of these to be negative. The only one that could be negative would be that y value. So, the x value. No, the y value, I was right, the y value. So we're looking at this one here, the 5 pi over 3 and the 300 degrees. For 9, we're dealing with the sine, the inverse of sine of the square root of 2 over 2. So y is going to equal the square root of 2 over 2. So looking at our unit circle, where is y the square root of 2 over 2? Well, y is the square root of 2 over 2 here, so that's 45 degrees and pi over 4 as well. For 10, we are given the inverse of sine of 0. So where is y? 0. Y is 0 here. So we are going to be at 0 degrees. And 0 degrees is the same thing as 0 radians. So you're just giving 0 and 0 degrees. For 16, since these numbers jump, I'm pretty sure that our directions change. Yes, find all possible values for each expression. So for 16 and 17, we're doing what we did for 2, 3, and 4. So for 16, we have cosine to the negative 1, so the inverse of cosine is 1. So where is x equal to 1? If we look at our unit circle, x is 1 at 0. So look at your values. You have 0 and 0 degrees. So your radian here is 0. So we're going to have the 0 plus 2 pi times n, where n is an integer. For 17, we have sine to the negative 1 of the square root of 3 over 2. So where is your y? The square root of 3 over 2. Look at your unit circle. Y is the square root of 3 over 2 at pi over 3. So keep the pi over 3, add the 2 pi times n. Where else is it the pi over, or the square root of 3 over 2, I'm sorry. The square root of 3 over 2 for y is also here at 2 pi over 3. So that we will add 2 pi times n to as well. For 18, we have the tangent to the negative first power of negative 1. So our tangent is our y divided by x. So where is y divided by x? Negative 1. If that's the case, we have to have same numbers, opposite signs. So same numbers, opposite signs are the square root of 2 over 2 and the square root of 2 over 2, but they have to be opposites. So it's going to be the 3 pi over 4 as well as the 7 pi over 4. From here, we just add 2 pi times n, and then we're done. For 18, for 19, we're working with restrictions. 19 through 24 tell us to evaluate each inverse trigonometric function, give your answer in both degrees and radians. So that is a dead giveaway that we're working with restrictions. For 19, we have the sine, so y is equal to the square root of 3 over 2. In your first and fourth quadrant, where is the square root of 3 over 2, your y value? So in the first and fourth quadrant for sine, where is your y value? The square root of 3 over 2. Here. And what are the values for degrees and radians that represent that? The pi over 3 and the 60 degrees. For 20, we have cosine to the negative 1 of negative 1, so x is equal to negative 1. So working with cosine, where is your x? Negative 1. It's here at pi and 180 degrees. For 21, we have tangent to the negative 1 is negative square root 3 over 3. So where is y over x? The negative square root 3 over 3. If that's the case, we're working with the square root of 3 over 2 and 1/2. One of these has to be negative. If you're only working with the first and fourth quadrant here, you're going to have to see which one is negative because of the fourth quadrant. Now, that tells you that your answer is going to come from the fourth quadrant. However, you don't know if it is the 5 pi over 3 or the 11 pi over 6. So work with these and see which one works best. For this, we are going to work with the square root of 3 over 2 divided by the 1/2. If we keep change flip, we're having the square root of 3 over 2 times 2 over 1. These would cancel, so it's just the square root of 3 over 1. That's not right. So flip the square root of 3 over 2 and see if that works, and the 1/2, see if that works. If we did 1/2 divided by the square root of 3 over 2, that would give us 1/2 times this 2 over the square root of 3. Your 2's would cancel, so then you would have 1 over the square root of 3, which simplifies to be the square root of 3 over 3. So this one works. This works. This was your y, this was your x. So where is your y, the 1/2, and the x, the square root of 3 over 2? Right here. So you're using the 330 degrees and the 11 pi over 6. Again, it's practically a guess and check kind of thing. You got to figure out which ones of these are going to give you the right answer when you divide the y and the x. For 2, we're working with the inverse of cosine that you get negative square root 3 over 2. So where is x, your negative square root 3 over 2? Remember, your cosine is your first and second quadrant. So within your first and second quadrant, where is x, the negative square root 3 over 2? Right here, which means 5 pi over 6 and 150 degrees. For 23, we're working with the tangent of -1 of the square root of 3. So the inverse of tangent is the square root of 3. Well, we did that up here, and we were working with the y divided by x is the square root of 3. And we worked with the square root of 3 over 2 divided by the 1/2, which gave us the square root of 3 over 2 times 2 over 1, which is just the square root of 3 over 1. So this is matching this. Positive, positive gives us a positive. We're getting this from the first quadrant. So where is your y, the square root of 3 over 2, and your x, the 1/2, in your first quadrant? At the pi over 6 and 30 degrees. For 24, we have the inverse of sine as the square root of 3. So where is our y value, the square root of 3, in the first and fourth quadrant? Well, there's no value that y is the square root of 3. So we have no solution.